Hi everyone, welcome to our next video on linear functions and graph chapter 6. In particular, today we'll be covering on 6.2 linear functions. So what's our lesson objective for this video is to use linear functions to help find outputs and inputs in the function, as well as to plot linear function on Cartesian graphs. Okay, now you may be thinking, what is a function? A function in English may recognized as a purpose. However, in a mathematical function, it has a totally different meaning. So, in general, a function assigns every object in set A to only one object in set B. What is this all about, right? Okay, maybe I will just give you a simpler example. All right. Okay, look a little at this diagram. Over here, we have a mathematical equation in the center. Alright, y equals to 3x. This is what we call a mathematical function. And what the mathematical function do is like a machine. It accepts a certain input. Alright, input means what it takes in, and it produces an output. What it produces basically, yes. So let's take a look at the example of x. X normally is our input values. So we will substitute x into the equation, and then by substituting equation, we get a certain output value y, and then it comes out on the other side. Okay, so let's see how this magic works. So first, let's investigate about what happens when we have an input value of x of -4. Alright, so first thing, I have -4, I duplicate it, I send one copy into this function machine. So it goes into the function machine, substitute in the equation, 3 times -4, and it produces an output value of -12. Right? After I get my output, I will then pair up my inputs and outputs, and then this forms in my data table. So what this data table is trying to say that for every x input of -4, my output is always -12. Which makes sense, right? Because our mathematical function y equals 3x is just saying that every time I want to produce an output, I'll multiply 3 to the input value. So I'll substitute the value into the machine, and I'll produce an output value of -12. Right? Now, let's think about it. What happens if I input the value of -2? Okay, so we take the value of -2, we substitute it into our x over here. 3 times -2, what does that give you? Then I'll give you -6. Agree? You can do it for the following values as well. 0 times 3 gives you 0, 2 times 3 gives you 6, 4 times 3 gives you 12. And then that is how we are able to fill up the entire table with the respective input values as well as the output values. Is it clear so far? Okay, now let's try to link this back to our Cartesian coordinates that we learned in the previous video. Do you notice that I can group up these x and y values to form our Cartesian coordinates? -4, -12, -2, -6, 0, 0, so on and so forth. What do you notice about this? Alright, these are just Cartesian coordinates by themselves. But what happens if we plot them out onto our Cartesian graph? So we have our Cartesian graph over here. Now let's look at what happened when we plot them out. So we have our x-axis and the y-axis. So let's find where is this -4, -12 at. Okay, look at the x-axis. We go to our position of -4, and we go all the way down to -12. This is our point, -4, -12. Next thing, we can do the same for -2, -6. So we first go to our x-axis, we go all the way down to -2, then we go down to -6. -6 should be over here, and this is our next point. Okay, of course the third point, 0, 0, right, dead center in the graph. Okay, we can do all so on and so forth for 2, 6 as well as 4, 12. Now, do you notice there's a pattern between all of these 5 points? Correct. They form a straight line. And in this case, this straight line is represented by the linear function y equals 3x. Okay, so I hope you're able to get a better idea of how Cartesian coordinates is linked to linear functions. Alright, linear function being this equation here. Alright, so just to summarize, what we learned in this video is that when we have a linear function, a certain equation, y equals to something x, alright, what we can do is we can use this function to get a set of inputs and outputs. Inputs being your x and outputs being your y. After we get a set of inputs and outputs, for example, we have 5 sets of inputs and outputs, we are able to plot them out onto our Cartesian graph using the coordinates here. So using the table, I can form these 5 coordinates and I'll plot out on this point. Now in this particular chapter, we are studying linear graphs. Linear graph just means straight line. So all of your points should form a very nice straight line which you can use a ruler to draw them out on the graph. Of course, if your points do not line up, probably means you did a mistake somewhere. Alright, so please go and check your answer. Okay, let's look at some practice question. Okay, this question we have the equation of a function is y equals to 3x minus 5. They want you to find the value of y when x equals to 3. Okay, so this equation over here is a function used to find the value of x and y respectively based on the question. So our part A, what you need to do is just substitution. Alright, we learned back in the previous chapter on mathematical formula. Substitution just means to replace the position of x with its respective value. In this case, 3. So we have our equation of our function. We substitute x with the value of 3 into here. Use your calculator and you just get a y value of 4. And that's your answer. Now for part B is a bit different. Alright, part B we still do substitution, but instead of substituting the value of x, now we substitute the value of y. So same thing, using our equation, we substitute the value of y equals to 10. Alright, and then we do our linear equation. What we do in linear equation, we make x a subject, and ultimately we get x equals to 5. Is that okay? Key skill used in this question is just substitution. Now, next question we have is a data table over here. We have 5x value, which are your inputs, -2 to 2. They ask you to fill in the missing values in the table. Same thing, similar to what we did in our previous question. We just have to substitute the value of x into this equation and then use our calculator to find out what are the respective y values. Okay? Can you do that now? Okay, once you get your answer, alright, check with the answers in the video. Okay, so you should get -7, -5, -3, -1, and 1. And in part B, right, they request you to plot the graph of y equals to 2x minus 3 from x equals to -2 to x equals to 2, which is just nice the entire range of our data table. So what I'm going to do is in our Cartesian coordinates, our Cartesian graph, x and y, we're going to plot out the 5 points over here. -2, common -7, -1, common -5, so on and so forth. So after you plot out the 5 points by marking a x onto the graph, afterwards use a pencil to draw a straight line through these 5 points and label the graph with our equation. Is that okay? So this is normally a common question that will come out in your learning review or your EOY. Alright, how the marks are awarded? The 1 mark is given for the proper plotting of the points. Right? So as long as all the points are plotted correctly, you get 1 mark. Next is if you were to use a straight line and cut every single line, every single point to form a straight line, that's your 2nd mark. Okay, do you need to write the coordinates for each of the points plotted? You don't need to, but I'm just demonstrating here for clarity purposes. Alright? Okay, good. So of course, word of caution, always draw your graphs using pencil. Okay, next. So this is also a typical question that can come out for this chapter. So the equation of a function in y equals 2x minus 3, which is what we did just now. Part B asks you to show that the point 5, 7 lies on the line y equals 2x minus 3. Now, if we were to go back to our previous graph, we cannot find the value of x equals to 5, right? Sometimes we don't have the luxury of referring to the graph to find out its y value. So what do we do instead? Alright, we analyze the question. These coordinates 5, 7, what does it tell you? Okay, it tells you that when your x value is 5, your input of the function, you should get an output value of 7, which is your y value. This is important information that you need to extract from the question. So you know that x equals to 5 and y equals to 7. How do you verify this? So what you're going to do is substitution. So substitute the value of x equals to 5 into a function and check if your output value is indeed 7, y equals to 7. So we do our steps, substitute x equals to 5 into the equation, use our calculator, we will get y equals to 7. It matches what the question requires. So this tells us that indeed the coordinate 5, 7 lies on the line y equals 2x minus 3. Okay, so now let's look at part C. Part C asks you show that the point 1, 3 does not lie on the point, lie on the line. Okay, how do we do it? Similar step. First, extract the information that the point 1, 3 tells us that the value of x is 1 and the value of y is 3. Okay, similarly, use substitution. Alright, substitute the value of x equals to 1 into the function. Alright, so we get y equals to 2x minus 3. Substitute x with 1. And then it turns out that indeed our y value does not match with what the question gave us. Our y value obtained is -2, but the y value in the question is 3. So because the y value don't match up, hence the point 1, 3 does not lie on the line. Okay? So I hope after this practice question, you get a better idea of what linear function represent, how we can use the equation to get our input and output values, and to determine whether a certain point lies on the line of the question. Okay? If not, then see you in the next video. Bye bye.